We usually think of AI as something that just follows our instructions, kind of like an actor reading from a script. But what happens when that AI starts writing the script itself? That's what we're talking about today, the evolution of AI agents. A huge shift from being simple actors to becoming the architects of their own solutions.
And this really isn't science fiction anymore. It's the central question driving so much AI research right now. We're going to explore how an agent can go from simply using the tools it's given to actively building brand new ones to solve problems it has never even seen before.
All right, so here's the game plan. We'll start with the rise of these AI agents, then dig into two major challenges they're up against. After that, we'll see the breakthroughs that are making them so much more capable, how that sparks an evolution revolution, and finally, we'll take a peek at our increasingly autonomous future. Okay, let's kick things off at the beginning. How did we even get here? How did we go from basic language models to these AI agents that can actually do things in the real world? So, meet our main character, the AI agent. And no, this isn't just another chatbot you might have talked to. An agent can actually do things. It can interact with software, use digital tools, and carry out tasks to get a job done. It's an actor on the stage, not just a voice from offstage. So what's the secret sauce?
Well, the key is that an agent pairs a large language model, that's the brain, with a set of external tools. Think of things like a calculator, a search engine, or a code interpreter. These tools are what let it see, reason, and actually execute on a plan. Without tools, an AI is just a thinker. With them, it becomes a doer.
Okay, so agents sound great, right? But it's not that simple. For them to become truly autonomous, they've got to overcome two massive hurdles. And these are the core problems that researchers are racing to solve as we speak. First up is the library problem. Imagine you have a library with thousands of tools. How does the agent find the one perfect tool it needs without getting lost? And second, you've got the self-taught problem. How can an agent learn to use a new tool if nobody gives it a perfect step-by-step instruction manual? To really wrap your head around that library problem, get a load of this number. Recent research showed that to give an agent its full toolbox, it might have to process over 248,000 tokens. That is literally like forcing an expert to read an entire library from cover to cover before they can answer a single, simple question. It's slow, it's expensive, and frankly, it just overwhelms the AI.
And that self-taught problem? Well, a recent paper puts it perfectly. Current methods often require what they call curated gold tool use demonstrations. Basically, creating these perfect, human-made examples for every single tool is incredibly expensive and time-consuming. It's a huge bottleneck, and it just doesn't scale. So, we've got these two big, hairy problems. How are researchers tackling them? Let's dive into two really clever breakthrough solutions that are changing the game.
Okay, to crack the library problem, a framework from Google researchers called MCP0 completely flips the script. Instead of force-feeding the agent the entire library of tools, it just lets the agent ask for the specific tool it needs right when it needs it. The agent sees it has a gap, it describes the tool it wants, and boom, a routing system finds and delivers it on demand. And the result? It's pretty staggering. A 98% reduction in the number of tokens the agent has to deal with. I mean, just look at this chart. This approach slashes the cost compared to the old way, making the agent faster, cheaper, and way, way more efficient. Now, for that self-taught problem, the solution is just as elegant. It's basically a self-training loop. The agent just tries to get a task done. Then, it looks back at all its attempts and automatically figures out which ones actually worked. Then, it retrains itself, using only those successful attempts as its new examples. In other words, it learns directly from its own wins, no human teacher needed. Now, you might see a 3.7% accuracy boost and think, is that a big deal? But here's why it's so important. This was on PopQA, a dataset full of obscure questions designed to test knowledge that an AI couldn't have just memorized. This proves that agents learn best when you push them out of their comfort zone, when they truly need the tools to figure things out. Okay, so finding and using tools better, that's awesome. But it's really just the beginning. Let's zoom out now because we're not just talking about learning a few new tricks. We're talking about a full-blown revolution in how AI can evolve. This leads us to the next big frontier, the self-evolving agent. This is where things get really wild. We're talking about an AI that doesn't just learn how to use its tools better, but can autonomously improve its own core components. It's a fundamental shift from an agent that learns to one that truly evolves.
But that begs the question, right? If an agent evolves, what parts of it are actually changing? Is it just getting a bigger brain, or is it learning new skills, or is it thinking in a totally new way? Well, the answer seems to be all of the above, and it breaks down into 4 key pillars.
Researchers have broken it down into what they call the 4 pillars of self-evolution. You've got the models, which is the agent's core brain; the context, which is its working memory and what it pays attention to; the tools, the actual skills it has; and even its architecture, the very workflow it uses to think.
So first, an agent can evolve its core model, its fundamental intelligence, and its context, learning what's most important to focus on. It's like upgrading both your brain's processing power and its ability to concentrate, all at the same time. But it doesn't stop there. It can also evolve its tools by creating brand new skills out of thin air, and even its architecture, changing the fundamental way it organizes its thoughts. That's like a master craftsman who not only forges new tools, but also redesigns their entire workshop for maximum efficiency.
This brings us to the really exciting part. What does this all mean for the future? Where is this whole evolutionary path leading us? Let's get a glimpse of what could be coming next.
This quote really nails the synergy here. On one hand, you have systems like MCP0 that are amazing at finding tools that already exist. On the other, you have systems like Alita that can just build a new tool from scratch when it needs one. You can probably see where this is going.
When you put these 2 ideas together, you get this incredible self-improving loop. An agent looks for a tool, it's not there, fine, it just builds one. And then it adds that new tool to the library for itself and other agents to use later. This creates an ecosystem that can grow its own capabilities, potentially forever.
So we're really seeing a transition from AI that's just an actor to AI that's an architect. And it leaves us with a pretty big question. When our agents can not only learn and adapt, but also build their own tools and fundamentally evolve, what are the grand challenges they're going to solve next?